Welcome guys. Today we will be doing the experiment 6 of the DLIC practical series. Today we have with us inverting comparator. So what does this inverting comparator actually do? We have this V reference which is 2.5 volts over here. So every time we get a pulse value greater than 2.5 volts, the inverting comparator gets active. So we will be seeing how it works. So, okay. Here we go. We just put our one of the probe over here and one of the probes over here. This is our V in and V out. And here we can see how our output looks exactly like. So I'll just like to explain a bit on this. So this is the Vref voltage above which the inverting comparator starts working. This is the minimum voltage it will require, above it which it will start working. So to this there are various variations available. So we will be looking to a zero crossing detector circuit which is already open. I have made a few circuits just for our convenience. So when we talk about a zero crossing detector, here the only change with the prior circuit, the inverting comparator circuit, is that this is connected to the ground terminal. So whenever we see, whenever the ground terminal is crossed, we'll see the output. So we'll go for the output over here. So again will be, this is our circuit. Here we place our input probe. So we'll be seeing it individually. We can see a sinusoidal, nice sinusoidal wave. So now we'll go to the output part and so this is how we see the output part. So every time this is transitioning between the plus VSAT and negative VSAT range. So every time it crosses a zero, we see it the negative VSAT also changes to positive VSAT. Similarly, when at this point when it is crossing zero, we see again it is coming to negative VSAT, again it is going to positive VSAT. So this is a cycle which goes on happening. This is what we is about the zero crossing detector. Moving forward, we'll be looking at the time marker generator. Okay, so somewhat this circuit is similar to our. Just a second. This circuit is somewhat similar to our zero crossing detector circuit. Here we have a capacitance and resistors connection and a diode. So this is used and the diode is used for holding the voltage. So as we go, we'll be looking forward for the output. So here we keep our probe and this is, so we can see some spikes over here. So these are due to this V2 voltage. So this is about the time marker generator. Now we will be moving forward to our sample and hold circuit. So we have an NMOS over here. What does a sample and hold circuit does? So above a particular pulse of value, a sample and hold circuit, what it does is when this is triggered on, it will sample, and when it is triggered on, it will hold. So this is how the sample and hold circuit works. So we'll be looking at its output shortly. So this is how our sinusoidal will look like. And this is our output. Oh, sorry guys, just a minute. I think there's some issue. Yeah. Sorry for the interruption, guys. So this is how it will be looking. So basically, what we are seeing over here is for a particular instant of time it is being sampled, and for a particular instant of time it is being hold. So that depends on at the pulse intervals we get over here. If this is triggered on, we'll sample the waves, and if this is off, then we'll hold the waves. So this is about the DLIC experiment 6, where we saw different comparators. First we saw inverting comparator. Similarly, this is the with the inverting comparator, the VREF was connected to the inverting terminal. With the non-inverting comparator, we will be connecting it over here. This is the minor difference between the inverting comparator and the non-inverting comparator. We saw different variations to the inverting comparator. We saw the sample and hold circuit, where this triggering is important for the sample and hold functions. We saw a time marker generator circuit, which is somewhat similar to the zero crossing detector circuit with just a R and C combination and a diode over here present. Similarly, we saw a zero crossing detector uh, where the voltage changes basis of the triggers from plus V sat to minus V sat on the basis of the zero crossing as we see. So this was all about our DLIC practical checks, guys. Thank you for listening.